Hi, I'm Janna Garafolo, Director of Automotive Applications Engineering with NXP, and I'm here to show you today how NXP's systems expertise and S32 CoreRide platform can accelerate the journey to SDVs for automakers. The demo that I have here focuses on our new S32N 5nm automotive processor. This is based on the ARM R52 real-time cores. Here, the S32N is serving as the vehicle's central compute. This is doing the essential functions for vehicle dynamics, those real-time, safety-critical deterministic applications running in the R52 cores. Around the S32N central compute, we have 4 different zone controllers managed by S32K344 devices, controlling applications such as window lift, headlights, and electric motor. We also have 2 smart actuators. One is the S32K1, driving the BMS system, and then over here on the other side of the platform, S32M2 as a smart actuator for our HVAC system. You can see that this is a vehicle architecture completely enabled by the S32 CoreRide system. I'm going to show you a couple of use cases of how this makes software-defined vehicles easy to create and actually allows automakers to really fully use the benefits of a software-defined vehicle. So on the left-hand screen, what you see here is the architecture of R52 cores that are running inside the S32N. Each block represents a single R52 core. You can see some are running individually for non-safety critical applications, and some are running in parallel in lockstep. Those are 2 cores operating together to give us ASIL-D functional safety. You can see the dotted lines around the cores is signifying the virtual ECUs that are running in the chip. This is our method of providing hardware isolation so that we can have safety critical and non-safety critical applications running in the same processor together. This is allowing us to consolidate what typically are individual ECUs or boxes inside the vehicle into a single processor, saving BOM costs and also saving hardware wiring. This screen over here shows an example of what might be happening in the cloud using data from the vehicle. So for example, through our smart actuator, taking data from the battery and using some AI to predict battery life dependent on the way that the vehicle is being driven. And then also taking data from the HVAC system to predict the health of different components of the HVAC system to allow us to do predictive maintenance. So basically using data intelligence in the cloud to monitor and improve vehicle health. Okay, now to go to the demo, I'm going to show you a couple of use cases of how NXP's S32 CoreRide platform enables SDV features. So we're going to start with personalization option. The key here is that this is a software update that the consumer or the driver can purchase after they've bought the vehicle. Okay, so an opportunity for automakers to provide additional features after a car's been purchased. Okay, in this case, you can see on the vehicle cockpit that the driver has a message that there's a software package available to personalize the vehicle. So the driver is going to purchase the software package. It's going to be downloaded into the central vehicle computer over the cloud. And once it's ready to run, we'll see that the vehicle personalizes the way that it functions and feels dependent on the driver preferences. This driver here prefers a very eco-friendly, energy-efficient vehicle operation. So when they get in the car, the torque control energy management is running at highest efficiency. Their battery range has extended a little bit. They prefer the cabin lighting to be really cool. It's green. The headlights and taillights have taken a very basic pattern. Basically, we've optimized the vehicle to use as little energy as possible. And we can do that seamlessly through software updates to the variety of vehicle dynamics applications running in S32N that can all be easily updated via software inside the single processor. Now, if I take another driver in the family, this driver likes a much more sporty, aggressive type driving experience, and they get in the car. The torque management is much more aggressive. The headlights and taillights are much sportier. Cabin lighting changes color, and basically they have a much more aggressive type environment. We've even optimized the HVAC system to run at its max performance to cool the driver down. And again, you can see where we've made software updates inside the S32N processor for the various different applications that control the personality and the operation of the vehicle. So now for the second use case that I want to show you, I mentioned that we have multiple different ECUs consolidated into a single processor. What allows us to do this is the hardware isolation that we have available inside S32N. We have safety critical and non-safety critical applications running together inside a single processor. So we have configured virtual ECUs inside that processor to keep these applications from interfering with each other. So I want to show you an example of how that might look in an actual vehicle. So I am going to run our fault demonstration, and I'm going to force a fault in a non-safety critical application. You can see that the HVAC system here has experienced a fault. The fan stopped running. A fault is being communicated to the S32N. You can see that the fault is recognized in the application there in S32N. The rest of the car continues to run. This is a non-safety critical application. It's completely isolated inside the processor, so nothing else is interfered with in terms of performance and operation of the other applications. Now the driver gets a warning of the error in the cockpit as well. And you can see in the cloud, we've lost data from the HVAC system due to the fault, but we found a software update that's available. So I'm going to go ahead and run that software update to clear the fault. It'll be downloaded from the cloud, and software in the S32N will be updated just inside the virtual ECU that's running the HVAC system. And the HVAC system is now functional again, all while the car continues to maintain its operation. The key point here is that we are able to do this full hardware isolation inside the S32N processor, which enables the consolidation that is important for software-defined vehicles. So thank you very much. This is an example of how NXP enables software-defined vehicles using our S32 CoreRide platform.